Hello friends, welcome to the YouTube channel of Hasmukh Goswami College of Engineering. I am Jaideep Jadia, Assistant Professor in Civil Engineering Department. My topic is how to draw shear force diagram and bending moment diagram. For that, prerequisite is what is shear force and bending moment. So shear force is algebraic sum of unbalanced vertical forces either to the left or right of the section. For that you have to assume sign convention. Let us see, this is the section and this is the left side and this will be the right side. Left side upward is considered positive and right hand side downward force is considered as positive. Opposite to the upward, left hand side downward is considered as negative and on right hand side upward is considered negative. Okay. Now next, what is bending moment? So it is the algebraic sum of moment either to the left or right of the section and sign convention. So this will be the section, left and right section. Left clockwise moment is considered as positive. On right hand side anti-clockwise moment is considered positive. And here left hand side anti-clockwise moment is considered as negative and on right hand side clockwise moment is considered negative. So this is the first prerequisite about the section. Let us see how to draw shear force diagram and bending moment diagram for simply supported beam. So here simply supported beam is given in which point load of 10 kN and uniformly distributed load of 5 kN per meter is given and span of UDL is 2 meter. So for calculation, first of all, step number 1, we have to calculate support reaction. So for support reaction calculation, we need to understand support condition. So here at the left hand, hinge support is given and on right hand, roller support is given. Hinge support will generate two reactions. First reaction is vertical reaction and second reaction is horizontal reaction. And roller support will generate only one reaction, which is vertical reaction. Here in this beam there is no horizontal load, so reaction generated at A point is 0. Okay, so you have to calculate first of all support reaction Rm and Rb. So for calculation of support reaction, we have to use equilibrium condition. So there are three equilibrium conditions: sigma m equal to 0, sigma v equal to 0 and sigma h equal to 0. So for calculation of support reaction, first use sigma m equal to 0 and for that take moment at left support A. We are taking moment at A point, so go to the other end. So here reaction Rb is, so moment means force into perpendicular distance. So now force is Rb and perpendicular distance from A point is 2 plus 2 plus 1, 5. So Rb into 5. Now we are using condition sigma m equal to 0, means anti-clockwise moment equal to clockwise moment. So Rb into 5. So first of all, the signs of this Rb force about A is anti-clockwise. So we are using at anti-clockwise side. Now next, due to this 10 kN point load and now moment calculation, you need distance from A point. So 10 kN and distance from A is 1 meter. So 10 into 1, now moment sign. So 10 kN is in downward direction and about A rotation is clockwise. So it will be on clockwise side. So Rb into 5 equal to 10 into 1. Now next, uniformly distributed load is given. So first of all, you have to convert this UDL into point load. So for that, multiply UDL intensity with the span of UDL. So 5 into 2. Apply at the center of this UDL span, which is 2 meter. So center will be 1 meter. Now perpendicular distance of this UDL to point load from A point. So 1 plus 2, 3 plus center 1 meter. So we will get 4. So moment means force into perpendicular distance. Force is 5 into 2 and perpendicular distance from this A point is 4. So now simplify. RB into 5 equal to 10 plus 5 into 2, 10 into 4, 40. So 40. Now RB equal to 10 plus 40, 50. Divide by 5. So we will get 10 kilonewton. Now use second equilibrium condition, which is sigma V equal to 0, which means upward force is equal to downward forces. So there are two upward forces, RA and RB, and two downward forces. First one is point load and second one is UDL. So unknown is RA. So RA equal to downward force. So downward force is due to point load plus UDL minus RB. Now value of RB is 10. So RA equal to 10 plus 10 minus 10. So you will get the value of RA 10. So these are the first calculation of support reaction, in which we have defined support reaction value RA as 10 kilonewton and RB as 10 kilonewton. Now next calculation is for shear force. So shear force, as I said, it is the algebraic sum of all vertical forces either to the left of the section or right of the section. So first of all, the calculation of shear force at A point. So you have to draw a section at A point and consider left hand side forces for calculation. So at the section just to the right there is support reaction, which is RA, and value of RA is 10 kilonewton. So at A you will get shear force 10 kilonewton. Now next to the A point is C point. So now draw section at the C point, and shear force means algebraic sum of all vertical forces either to the left or right of the section. We are using left hand side section. So C point से लेफ्ट हैंड साइड में कितने फोर्सेस है, तो यहाँ पे आप देखोगे. सो सबसे पहले है 10 kilonewton upward force and 10 kilonewton downward force. Okay, upward is positive and downward is negative. So at C point 10 minus 10. So we will get the value of shear force at C 0. Now next to the C point is D point. Okay, so now draw a section at D point and use left hand side section. So left hand side of the D, there is two forces. First one is support reaction RA in upward direction, and at C point load of 10 kilonewton. So 10 minus 10, you will get shear force at D 0 kilonewton. Now at B point, which is the next to the D, so draw section at the B point, and shear force means algebraic sum of all vertical forces either to the left or right of the section. So on left hand side first is 10 kilonewton support reaction, then at C point there is 10 kilonewton downward force, and at D to B portion there is UDL UDL is converted into point load by multiplying with span of UDL. Upward is considered positive and downward is considered negative, as I said in prerequisites. So here we can see on left hand side upward 10 kilonewton minus at C point which is downward, on left hand side downward is negative, minus UDL is also downward in left hand side, so 5 into 2. So simplifying this, 10 minus 10, 0, minus 5 into 2 minus 10. So value of shear force at B is minus 10 kilonewton. Now next is bending moment calculation. So at A point and B point the value of moment is 0 because at left hand support there is hinge support and on right hand side there is roller support. So these type of support have 0 moment. So at A point 0 kilonewton meter and at B point 0 kilonewton meter. Now calculation of moment at C. So moment means force into perpendicular distance and bending moment means algebraic sum of moment either to the left or right of the section. So we are taking section at C and using left hand side portion for calculation of bending moment. So on left hand side there is only one force which is support reaction Ra and perpendicular distance from C point is 1. So 10 into 1. Now sine. So left hand side of the section due to this upward sign moment is clockwise. So positive sign 10 into 1, 10 kilonewton into meter. Now next to the C point which is D point. So calculation of moment at D point can be done using left hand side section and right hand side section. Both will give same answer. First of all calculate bending moment at D using left hand side section. So on left hand side here we can see there are two forces. First one is support reaction and second one is point load. So moment means force into perpendicular distance. So from D point due to this support reaction perpendicular distance is 1 plus 2. So 3. So Ra into 3. Now the value of Ra is 10. So 10 into 3. Now moment direction above D is clockwise. On left hand side clockwise moment is positive. Now next at C point here we can see downward direction point load is given and above D rotation is anti-clockwise. So on left hand side anti-clockwise moment is negative and perpendicular distance from this 10 kilonewton above D is 2. So 10 into 2 due to anti-clockwise on left hand side use negative sign. So 10 into 3 30 minus 10 into 2 20, 30 minus 20 you will get answer 10 kilonewton meter. So this will be the answer using left hand side of the section. Now calculate moment at D using right hand side of the section. On right hand side of the section there are two forces. First one is support reaction and second one is due to UDL. So moment means force into perpendicular distance. So we are calculating moment at D on right hand side. So moment means force into perpendicular distance. So RB is 10 and perpendicular distance from D point is 2. So 10 into 2. Now the sign. So on right hand side anti-clockwise moment is positive and clockwise moment is negative, as I said in prerequisite. So 10 into 2 consider as positive. Now next moment is due to this UDL. So first of all 5 into 2 apply at the center, UDL to point load conversion, and from center to the perpendicular distance is 1. So 5 into 2 is force and 1 is perpendicular distance. So 5 into 2 force and 1 is perpendicular distance. Now sign. So this will be in downward direction and about the rotation is clockwise. But we are using right hand side of the section. On right hand side of the section, clockwise moment is negative. So minus 5 into 2 into 1. So simplifying this, 10 into 2 20 minus 5 into 2 into 1 10. So we will get 20 minus 10 kilonewton meter. So by using this both side of the section we are getting same answer. Now how to draw shear force diagram. So for calculation of shear force diagram, draw first of all horizontal line which indicates 0 0 level. Above this 0 0 line which is the positive side, and above below this 0 0 line which is negative. So now rule is for vertical force shear force diagram is vertical line. Okay. Next, for no load between points shear force line is horizontal, and for uniformly distributed load this will be linear incline. So here first of all at A point shear force value is 10 kilonewton. So 0 and 10. Draw vertical line because point load is given. Now from A to C point there is no load. It means you have to draw horizontal line. Now at C point there is point load, and point load is in downward direction, and value of shear force at C is 0. So draw a vertical line and connect with 0 0 line. Now from C to D point there is no load, and if there is no load shear force line is horizontal. So draw horizontal line from C to D at 0 0 level. Now at D point the value of shear force is 0. Okay. Now at B point you are getting answer minus 10, and minus 10 is due to this uniformly distributed load, and if uniformly distributed load then draw inclined line below 0 0 level because answer is minus 10, and at B point you are getting support reaction RB 10 which is in upward direction. So draw a vertical line and connect that to the 0 0 level. So this will be the shear force diagram. Now to draw bending moment diagram, for that draw 0 0 level line, above 0 0 line positive side and below 0 0 line negative side. Okay, and here at A point you are getting moment 0, and at B point you are getting moment 0. Now at C point you are getting answer of bending moment 10 kilonewton into meter. Here there is no load between 2 points. In that case bending moment diagram is inclined line. So answer is 10 at C and 0 at A. So connect with this inclined straight line. Now between C to D point there is no load. It means your line is straight, and answer at B point is 10 kilonewton. So connect with horizontal line. Now between D to B point there is uniformly distributed load. In that case bending moment diagram is parabolic curve. Okay, and the value of bending moment at B point is 0. So connect with 0 0 line. So this will be the bending moment diagram for this B. Thank you for watching the video. If you like it, please subscribe, like and share.